Guide to Space podcast. I'm your host, and
Who are you?
They know me. I'm everyone's favorite astronomy podcaster.
Alright. Well, I'm Edwin, and we have to do this a little bit early because check-in is at 8 and it's like 7:20.
Yeah.
Alright, I saw it. What are we talking about?
We're talking about exoplanets and extraterrestrial life in the universe today. So we're kind of talking about planet habitability, weird planets, the huge variance that we have in the universe in terms of Earths like ours, and also the Fermi Paradox. If the universe is so huge, why haven't we seen any sort of life signs or any sort of activity from anywhere outside of our planet in the universe? So, where shall we start? I generally start with asking a question to kind of get like some perspectives settled in, maybe some opposing perspectives. Do you think life exists in our universe outside of Earth?
I would say yes, because the amount of stars and the amount of planets that are out there are like unimaginable. You have no idea how many are out there, and it's like basically infinite.
Yeah.
So that combined with like the probability of life existing is like, it makes it somewhat probable that life exists.
But like, how would it exist though? Like, we can see life, but as far as I know, I mean, there are some theories, but we haven't seen or like found a way for unalive objects like rocks, nucleic acids by themselves form actual living organisms.
I mean, it happened on Earth, so why can't it happen somewhere else?
Then why haven't we seen it?
Well, how far can we see in the universe?
Around the observable universe, the snapshot of the universe that we can see with the best telescopes is around 90 billion light years in diameter. And even that has basically infinite stars, as you said.
But can you zoom into like the planets and see if there's life on that planet?
I mean, for Earth, like if there was a planet, I know, but it also has to be in the range where life has been prevalent. So
the habitable zone in the solar systems.
Yeah, and like it also has to be in like the right time frame for an outside civilization to observe us. Let's say someone in the Andromeda galaxy would see us millions and millions of years ago, right? Because of the time it takes light to travel there. So they would likely not see humans at all. But still, if they were as advanced as we are right now, they would very well be able to detect life because of the organic biomolecules that we leave in the atmosphere. Obviously, life doesn't have to be in the same way as here, but with the James Webb Telescope, for example, scientists can now see the molecular composition of atmospheres. Like, I think it was HHD 12b. Which had carbon dioxide in its atmosphere, which, as we know of, is only produced by living organisms here on Earth.
So what does that suggest about that planet?
That life is there, baby? Yeah, but like living things can create carbon dioxide like artificially in labs. It doesn't like have to be created by living things, but it has to be a really advanced species for them to create it artificially.
But it's just a molecule with 3 atoms. How hard can it be?
How hard can it be is right. So, okay. You think aliens exist then?
Yes.
To what extent do you think they exist? Like, what, maybe like millions of other planets like ours?
Maybe not millions, but at least one. There's gotta be at least one out there. Maybe not like intelligent life, but like in the form of bacteria or something. It's simpler.
Yeah, like I also think that aliens exist in the universe somewhere other than the Earth, um, and like, but we also have to provide some reasoning for why we think that. Like, just because it's improbable, sorry, probable, because of the huge size of our universe, just saying that life should exist, I don't think it's enough on itself to say it does. So we have to provide some sort of argument, and there are quite a few for the Fermi Paradox, which is one of my favorite topics. And I made a presentation which is on our channel. You can watch it right now. The vast size of our universe in extraterrestrial life, and we explored four main solutions to the Fermi Paradox in that presentation. I don't know if you love this topic as much as me. We have four kind of proposed ideas. One is the dark forest hypothesis.
What is that? Can you like explain each of these hypotheses?
Yeah, dark forest hypothesis is basically comparing the vast universe to, let's say, a dark forest, as it's in the name of the hypothesis, on Earth. So if you were like the only alive thing as you see in a dark forest, would you make any noise, or would you make yourself able to be detected by other forms of life? Like, would you make a sound in a dark forest with potentially tigers or wolves?
So
Or
it's just like the fear of the unknown.
Yes.
Are you willing to beat the fear of the unknown?
Exactly. So it's like, it says that life, and even like super advanced life, even more advanced than humans, are out there in the universe, but they're just not making any noise and trying to
keep hidden.
Yes, trying to hide their signs as much as possible, so that because of the fear of like a much highly advanced civilization than them, let's say we are to tigers or animals here on Earth, because of the fear of them existing and being potentially hazardous to their lives, they hide in the vast universe, so that's why we can't see them. And there is the second one, the zoo hypothesis.
What are all these analogies with this? Right, continue.
It's one of the best parts, because when you're dealing with like super large scaled and kind of inapplicable sciences to daily life, like the names and analogies get crazier because there's nothing to compare it to. And the zoo hypothesis is exceptionally well named. It's once again comparing the state of the universe and life in the universe to some state in the Earth, where imagine like you're in a zoo, right? And let's say I don't know, monkeys are probably not the great example because they're kind of smart relatively to other animals. But let's say you're like viewing ants or worms. Think about yourself in this case. The zoo hypothesis puts a much highly advanced civilization in the case of you, the human, observing worms in a zoo. And the worms or ants or these relatively much lower civilizations can't even comprehend the existence of humans and you watching them.
So like they could be watching us and we wouldn't know.
Absolutely. That's like, this proposes like the existence of life that far above our level of comprehension and that much more advanced, being just incomprehensible to us. What do you think about this?
Well, then that means that it could exist. But we also have to think about like, we're separated by millions of light years, so we can't even reach them, or we would have to wait a long time to even be able to communicate with them.
Yeah, and like that brings us to the extent to which life on Earth is visible. Like, we only have radio waves that go out to like 100 light years as far as I know. Like, above that, they can't see actual like communications or technological advancements like emitting radio waves and like messages embedded in them. So they'd have to be and we know that in the 100 light year circumference, like let's say our cosmic neighborhood, there is no life. We can like easily observe that, of course, and so a life farther out in the universe would struggle to see us as an advanced civilization that we are because of the huge scale of the universe. So this one is kind of it's positive in the sense that it suggests there is life in the universe, but it's not in the sense that we might expect, and very, very much different than us, much more advanced. And then there is the Great Filter.
Oh no. Right.
The Great Filter the Great Filter hypothesis suggests that once a civilization reaches a certain point in its technological and civilizational advancement, it just erases itself out. Like, let's say a nuclear war. Exactly, you just hit it right on the dot. Nuclear warfare, and no, AI. Some technological advancement that a civilization inevitably reaches just erases them out in some way and is detrimental to them because they can't control it.
They just create a super intelligence.
Super AGI.
It just wipes them out.
Yeah, it's a possibility. I don't quite believe in this one. It doesn't sound very much sensible to me, because like not every life form has to be similar to us. Not every life form has to be as hostile as us to each other. Not every life form has to be dumb. Well, we're not dumb, but they can be much smarter than us and realize the consequences of such technologies and develop them much better than us. And also, they can be like of different nature than us. Silicon-based life instead of carbon-based is also very much possible. Like carbon is like one of the kind of rare and great elements for sustaining life. You're taking biology as well. Maybe they touched on this. My biology teacher kind of made me think about this. Is that carbon can form so many bonds because of it having four.
It's tetravalent.
Yes, exactly. They can form so many bonds and create very, very different and variant biomolecules that are able to sustain life, complex life. So silicon is also one of these atoms. I think it tetravalent. Just saying that life doesn't have to be. Life, at least life as we define it, like able to reproduce, and metabolize, homeostasis, and reaction to outside triggers. The way we define it, life can be much different than us, and that's why I don't think the Great Filter hypothesis is probable. What do you think about it, or the three ones I just listed so far?
Well, like I said, like I think life is more highly probable to be like some type of bacteria or a unicellular thing, because I mean it's less atoms.
Yeah,
to form molecules.
Definitely. So like, obviously, a single cell unicellular organism or single cells bacteria, they're much more likely to exist than macroorganisms like us or bears, because those already have single cells and bacteria as a prerequisite to existing, so they're obviously much more likely. But like, there's also the argument where just having a single cell appear from unalive things is so unlikely that the likeliness between it existing and a single cell existing and you and me existing is like nothing compared to just a single cell arising from unalive objects. What do you think about that? Like, how rare must it be for like carbon or hydrogen, these molecules, to form in such a specific way to have, like, as we know it, create a DNA structure, be able to sustain it in like a cell membrane, and have all of the right conditions for it to reproduce, and like just it getting into that orientation of a cell by itself without any life is just unfathomably rare.
I mean, it happened to Earth, why can't it happen again?
But
Earth,
do we know it happened to Earth? Like, it might also been like life may have been brought to Earth by like an asteroid with something like that, where Earth wasn't like the original source of life in the universe. Or like, just this ties into the last episode we did with Max, where Edwin briefly participated. Is it ties into like cosmology and the life period of the universe, because if the universe is like a truly infinite thing with like no Big Bang, no end, like a loop, in a sense, it might also have like if it's like an infinite time frame, there might have been life forever, right?
Yeah, it's like pi.
Yeah.
There's every single combination of every number inside of pi, since it's irrational and it's infinite.
In an infinite time frame, everything that can exist exists. So it's very well dependent on the lifetime of the universe as well. So the universe is kind of also similar to a living being. It's evolving, expanding, maybe even reproducing, which we will.
A bunch of parallel universes.
Exactly, the many worlds interpretation, which we will get into in another episode on the multiverse. But yeah, the one last thing that I didn't touch on for the Fermi Paradox is that there is no which we both don't believe in, but the fourth solution is that there is no paradox. That just life is so rare and Earth is the only place that there is, so there is no aliens. That's basically what there is no paradox means. So that could also very well be a solution, like if you look at it. But yeah, from the four of these, what do you think is more likely?
I think maybe the second one, the zoo one, because we can't even see them and we're like so minuscule in size. We can't even communicate in any way or form, so we don't know of their existence in the first place. And who knows, they could just be watching us right now, filming this podcast through the window over there.
I mean, we might never know, because like, just a worm, as we said, like, right? A worm is very well a living organism. It satisfies all points of life, and it just is unable to comprehend the existence of humans, the existence of basically anything in like a consciousness. Like, they can obviously have intuitive reactions to outside triggers, but they can't do math. They can't comprehend vocabulary. I haven't asked the worm recently, but I'm based on their behavior and kind of the experiments we've done with them, I'm speculating. So that makes sense too. I do think the zoo. I was going to say the Great Zoo. The zoo hypothesis is the most interesting too. Like, the other ones expect life to be in the form that we see it, like that we can comprehend, we can think about. But the zoo hypothesis, like, it doesn't have to be that way. It like opens the window up to things that just are beyond our comprehension. It could be lying in plain sight, but they're just so advanced, like harvesting dark energy. Like, we just talked about it. What is dark energy? We don't know. Maybe it's like a highly advanced sort of life that is just taking up space, but we can't understand or comprehend what it is. So, I don't know. I just made that up, by the way.
Maybe they found exotic
exotic matter? Yes, exactly. Exotic matter. And right now, I think we can transition to planets, exoplanets, and star systems as well. Also, looping back to the first episodes of stars, star types. What sort of life other than Earth? Like we have seen some planets in the shape and like atmospheric composition as the Earth. We haven't detected actual life, but we have detected water, planets very similar to the size of the Earth. But
are there planets with oxygen atmospheres?
yes, that planet I referred to. Yeah, planet names are just all over the place today, but I will put it. It was HHD12b or something. Has water and oxygen based atmosphere.
Bam, there you go, life.
There you go, life. But like, if you just completely erased humans and all living things, we could like still there would be water, there would be oxygen just in the atmosphere, right?
Yeah, but those are essential to life.
So like if any life touched it, there would be life for sure, but we don't know if they have.
Yeah, and also you have like hydrothermal vents in the bottom of the ocean, and that's like another source of like life. You know about that?
Yeah, I like yeah.
There's bacteria that feed off
Yes.
hydrothermal vents, and then like the change just continues.
Yeah, that like it would be unlikely for like water, oceans, and atmosphere to exist in like a stable state without any life containing them. Like with the so many cycles that we have here on Earth, humans drinking water, then dying and evaporating and going into the atmosphere. We have so many cycles that allow there to be stable water and oxygen atmosphere on Earth, and weather too is very important for that. So yeah, it has the exact condition for. So if there was life, it would definitely be able to exist. But the other kind of thing that's gatekeeping us is the traveling to a planet like that. That's outside of our cosmic neighborhood, so at least a couple light years away. And that brings us to, like, what can we do to travel? And because we won't be able to move faster than the speed of light. Obviously, photons don't have any mass, but we do. And we can't have negative mass. So a wormhole bending the fabric of space to. If you can't go fast, what do you do, Edwin?
Just bend the fabric of space.
Yeah, if you can't travel any faster, you shorten the distance that you want to go, right? It's very intuitive. You just cut down the road if you can't travel through the road fast enough. And if you loop in the road from, like, let's say a one-dimensional line, if you loop it back in, or even like just bend it without connecting them, the distance from here is much longer than the distance from here to here. So wormholes, I believe, is the future of interstellar and intergalactic travel in the universe, which will hopefully allow us to detect life,
But
actual life.
It's still theoretical. We haven't found exotic matter yet.
And like, knowing it exists is one thing. Like, knowing it can exist is one thing, but proving it does, or creating it by yourself, is a whole different thing. Like, no one on Earth has created life from unalive things.
I thought we were talking about wormholes. Where'd you get life from?
What?
You said you can't create life from unalive things.
Yeah, and
I thought we were talking about that.
no, wormholes too, but it's kind of similar because, like, it's much harder to, like, create wormholes, even if you can see that they can exist, right? We can see life exists, but creating life from unalive things is a whole different challenge for you. So actually using them is the biggest challenge right now, but they are theoretically possible if you think about Earth as the geometric shape of the universe, which if you are curious about, you should check out the fifth episode.
Crazy, bro.
Yeah. And you have to be the biggest advocate for yourself. If you're not going to like your own video, why would you expect anyone else to like it? Am I right? Like, if you yourself don't support yourself, why should anyone else do so? Always be the biggest advocate for yourself. And, anyways. So, did you think about any exoplanets or like weird planets that either exist or can like sustain life outside of oxygen, atmosphere, and water molecules on the surface?
I couldn't really research anything because I had too much homework.
Mm-hmm.
I barely even finished my history.
Yeah.
Reading.
Okay. Yeah. I mean,
Can we talk about like the Drake equation?
I mean, I was going to go into like a few. I just wrote down. They're not like actual. I will not. Actually, I might give the actual code name for the planets. I had a few written down, where not necessarily for life existing, but it's also exoplanets. So the more we know about planets, the more we can think how can life exist here, even if they don't initially. There is this planet 55 Cancri E that has rock raining rocks on its surface.
How did the rocks get out there in the first place?
So very similar to how rain forms on Earth.
You're gonna evaporate the rocks?
Yes, you're going to evaporate surface metal, and they're going to get so hot and so much relatively hotter than the surface, where they'll rise up. And also, this is, I believe, a tidally locked planet, which means that the same face is always facing the star in its system. So we have one side which is like, I don't know, 5 degrees Kelvin, and the other is like 3 billion degrees Kelvin. Okay, that might be a slight exaggeration, but the huge heat disparity is very.
So like the planet is, in its entirety, is half hot and half cold.
Yeah, that's a great way to describe it. It's half hot, half cold, and this rocks evaporating and turning into lava, turning into actually probably not lava, just in gaseous state in its atmosphere, and then cooling down once it reaches a certain peak. The atmosphere also gets colder. I mean, as it gets hotter, it rises. As it rises, because of the altitude, it's less close to the core.
As you get closer, as you get higher, the closer you are to the stars. So.
Yeah, but the thing is, like, we have like how many, God knows how many million kilometers to the star, and like a slight kilometric shift in that distance doesn't actually affect the heat temperature that much. But what does affect it is the huge lava explosions and thermal activity going on the surface and the heat of the core of the planet. So as you get farther from that, it changes a lot more than just a slight shift to the distance to the star. Exactly how in the northern hemisphere we're closer to the sun during winter, but farther away from it in the summer. So the slight shifts in distance to the star is not much apparent in planetary atmosphere, unfortunately. But I would like to. That's like one of the first questions I asked in 6th grade when I saw Skizu's topic, and was dumbfounded. And I realized, how is this not possible when you're closer than the super hot, extremely big object? But turns out there's extraordinary things in the universe and in our Earth that we haven't seen anywhere else. So we know rocks can rain, the more you know. And there's another planet HD 189,733b,
Oh my god.
which is, I believe, a Neptune-sized planet. And the highlight of this planet is it having glass shards or running around in its atmosphere with winds getting it to the speed faster than the speed of sound.
Oh my god.
So there are shards of glass storms that actually glass, like there are many kinds of glass. This is probably like some nitrogen based, I think. Yeah. Oh, silicate particles condense in rain glass. Yeah, water and silicate. Shards run around in the atmosphere faster than the speed of sound. Supersonic glass, sharp objects, traveling around the planet, and it gets easier to see how Earth is such a diamond in the rough for life existing in the universe. When we see some of the conditions that other planets and potentially aliens experience. And going into the theme of life existing but not in the way that we know it, in planets like this, like, it might be more favorable for creatures to live under the ground. Life can also exist very well deep under the sea, in like how fish are able to sustain life under, like, we have the moon of Saturn, Titan, where there are methane oceans, and some liquids like water have property where their solid state is less dense than the liquid state, which allows ice to come to the top and life existing under the sea, which is very interesting and very hard to detect, unfortunately. But we'll discover some ways of intergalactic travel that I will post the tutorials to in the second episode. So thank you so much, Edwin. Yeah, we had a great conversation, and yeah, you hopefully will find out about more exciting news and possible signs of life in the universe. I'll keep y'all updated, and we'll share some when we find some. And stay tuned for the next episode of the
Space podcast. Guide to space.
Guide to Space podcast. This is great. Max didn't know it, but you're a longtime follower of the channel, and we have some robotics going on as well. We have some compartments. This one actually, when plugged in,
Plug it in.
we gotta show this. Like this. Let's plug it in real quickly. Let's press one of those.
Alright. These are buttons.
And when you press either of them, it lights because it's a parallel
Logic gate.
Yeah.
Right.
Okay. See you, everybody. Have a great rest of your day. Bye-bye.